Hi there, welcome to my channel mathssl. I'm speaking Thaqib Latif. This is front of me the question 4 function. I'm gonna start the function question here. The question says a logarithm function I have front of me. The graph of f of x is equal to log of x to the base 1 over 3 is drawn below. Point A is the x-intercept of f and 3 and t lies on f. There is 3 and t lies on f. Calculate the value of t. So we need to find t, this one. The point 3 and t lies on the graph of f of x log of x to the base 1 over 3. To find the value of t, substitute the coordinates into the equation. So substitute the coordinates into the equation. So we got 3 and t. So first of all, we got f of x. So f of x, we have log of x to the base 1 over 3. So we're going to substitute 3 and t into this function to get the value of t. Now, y is equal to f of x. So substitute 3 and t into the function. So this is x, this is y. So it's going to be t is equal to log. So now rewrite the logarithm equation in exponential form. So now we need to find the value of 3. So 1 over 3 and t become power. Remember, we're using this formula. If y is equal to log of x to the base b, then if you need to find the value of x, we say x is equal to b power y. So this one I'm using here. So this power, 3 power I pull up, 3 power 1 I pull up become 3 negative 1, and power of t is equal to 3 and this is power 1. Now I'm going to solve here. So this is going to be 3 power negative t is equal to 3 power 1. Now in the same basis, I'm going to equate the exponents. So therefore, negative t is equal to power 1. So the bases are same. So I'm going to equate the exponents. So the negative t is equal to 1. So therefore, t going to be equal to negative 1. Both sides divided by negative 1. So the t is equal to negative 1. This is my final answer. Now the 4.2 says, write down the coordinates of A. Now we're looking at the x-intercept. A is the x-intercept. So set the function equal to 0 and solve for x. So we have now, the function we have now, therefore, f of x going to be equal to, now we have the value of t now. The function we have, f of x is equal to log of x to the base 1 over 3. Now is equal to 0, set is equal to 0 to find the x-intercept, log of x to the base 1 over 3. Now rewrite the equation again. We're going to apply the logarithm formula. So this time we need to find the x value. So the x going to be equal to 1 over 3 and then 0 become power. Now, so use the calculator. The answer going to be x is equal to 1. So therefore, the x coordinates we have, x value 1, y value 0. These are the x coordinates. 4.3 says, determine the equation of f inverse, the inverse of f in the form y is equal to. So we need to find this answer now. We have original function f of x is equal to log of x to the base 1 over 3. Now we need to find the f inverse. So first swap x and y. Must remember y is equal to f of x. You can say also like this, y is equal to log of x to the base 1 over 3. So swap x and y. So y become x and x become y. That is the first thing we need to do. Now solve for y. So again we're going to apply the logarithm formula. So the y is equal to 1 over 3, and always this will stay the base. 1 over 3 always stay the base, power x. For this is the equation of the f inverse. 4.4, write down the equation of the asymptote of f inverse. So original function we have f of x is equal to log of x to the base 1 over 3. The vertical asymptote for a basic logarithm function of the form y is equal to log of x to the base b is the y-axis, which has the equation x equal to 0. The original function is a logarithm function f of x is equal to log of x to the base 1 over 3. The vertical asymptote for a basic logarithm function that is x equal to 0. So the x is equal to 0. This is the vertical asymptote we have. So the f inverse of x asymptote will be, must remember, we swap x and y, so it's going to be opposite, so it's going to be y is equal to 0. So this is my final answer. 4.5, draw the graph of f inverse on the set of x's provided in the answer book. Clearly indicate the intercepts with the x's, the coordinates of one another point, and the asymptotes. So I'm going to sketch the graph. So this is the original function we have. This is the points 3 and negative 1 here, and this is the x-intercept 1 and 0, and x value is equal to 0, which means here all the way x value is 0 here. So this is your asymptote. The function shouldn't touch the y-axis. Now f inverse is going to be opposite of this one. So which means if this is a x-intercept 1 and 0, so that's, I'm going to swap around. There's going to be x is 0, y value 1. So the x is 0, y value 1 is somewhere here. This is also, I'm going to swap around this point, and these are the point 3 and negative 1. Inverse going to be negative 1 and 3. So the negative 1 and 3 is going to be negative 1, say negative 1 is here somewhere, and positive 3 on top somewhere there. So the negative 1 and positive 3 is going to be here. So we're going to start the graph here like this, and mustn't touch the x-axis, because this time y is equal to 0, horizontal asymptote. So the graph shouldn't touch the x. On the x-axis, y value is equal to 0. So this is the asymptote. So this f inverse shouldn't. So this f inverse mustn't touch the x-axis. So this is going to be f inverse graph. So let me draw nicely on the other side of the answer book. I always first draw the graph, then I plot the point. So this is my f inverse. This is going to be my f inverse. There is the point. It's going to be x value 1, y value 3, and this will become x value 0, y value 1. Obviously mustn't touch the y-axis because y is equal to 0 here. This is the asymptote. All the way on the y-axis, y value is equal to 0. So this is my f inverse graph. So this is the last question. He say the graph of h is obtained when f inverse is translated 5 units to the right. Determine the y values of h where x greater than 4. So we need to f inverse translated 5 units to the right? First we have to look at. So must remember, x is negative 1 here, x is negative 1 here. So translated 5 units to the right, this f inverse. So add negative 1, you add 5 here, become 4, positive 4 somewhere here. So it's going to be a positive 4. So this whole graph as well is x value 0, and if you add 5 become positive 5 somewhere, also going to be further here. So now x is 4. So the y value will stay the same. Same like this y value will stay the same here, and this y value will stay the same. Y value won't change. Y value will stay the same here. So 4 and 3, y value will be there because the graph translated horizontally. So 5 units to the right. So I roughly sketch the graph. So this is x value 4, y value 3. The y value don't change here. So now you're looking a range of y value x greater than 4. So the x greater than 4, all the value greater than 4 is this side, right hand side. So x greater than 4. So if you look nicely, greater than 4, the range will be between 0, because y value 0 here gonna be, because y value here 0, the graph is decreasing, between 0 and 3. So between 0 and 3, the y value between 0 and 3, the graph is, because that will be the range of the graph, because this graph is decreasing. So he looking the range, he said determine the range of y values for h of x. This is a new graph h of x. So this is your h of x, blue one now. So he said determine the range of y values for h of x when x greater than 4. So x greater than 4, this side, x greater than 4. On the right hand side, the greater than 4. So the y value, so this is a decreasing function. So between 0, y value 0 here. So between 0 and 3. So that will be the range of this graph when x greater than 4. So you're going to say between 0 and 3. So that is the range. That is the final answer for this question. Now if you look another point of view, because this is the f inverse, you must remember, na? The red one. So f inverse equation we have, that will be 1 over 3 power x. So this is the f inverse we have. A translation of 5 units to the right. So that will be your h of x. In x is a liar. In the f inverse, you're going to add 5. So you're going to write negative 5. If you move, shift to the, if translate 5 units to the right, so we're going to say negative 5, opposite. So now this new graph, 1 over 3, in the x gonna be x negative 5 now. So this is the h of x. Now when x value is 4, so what will happen? 1 over 3, x is 4 minus 5 is gonna be equal to 1 over 3 power negative 1. And that will be equal to, if you pull up, that will be equal to 3. So now that you can see this is a y value for h of x. So between 0 and 3, the asymptote is going to stay the same, which is y is equal to 0. So, but because the graph only shift horizontally to the right, so between 0 and 3, that will be the answer. This one I just show you the algebraically, but this is fine. It's 2 marks. You can give the answer graphically. You don't need to sketch the graph, but to make you understand, you can draw roughly to give the answer. So this is the question number 5, parabola and hyperbola. So the question says the graphs of f of x is equal to ax squared plus bx plus c and g of x is equal to negative 4 over x negative 3 plus 8 are drawn below. So this g of x is a hyperbola and this f of x is a parabola. So this f of x is a parabola and g of x is a hyperbola. P is the turning point of f and the point of intersection of the asymptotes of g. So the asymptotes of g is this is the point of intersection. They're meeting here. This is one is a horizontal asymptote and this is a vertical asymptote. So the graph intersect here. The coordinates of d is 5 and 6. M and T are the x-intercepts of f and g respectively. So this M and the T, they are the x-intercepts of parabola as well as for hyperbola. So they are the x-intercept of parabola and hyperbola. This is the information of the sketch. So the first question he asked, 5.1, write down the domain of G. So this is an easy question. The domain of G, this is g of x. The domain of g of x is equal to negative 4 over x negative 3 plus 8 is all real numbers except for the value of x that makes the denominator 0. So setting the denominator to 0. So we got x negative 3 is equal to 0. X is a liar. So the x is going to be equal to positive 3. So therefore the domain is all real numbers except 3. So you're going to write the answer. X is a real number, but x shouldn't be equal to positive 3. So you don't need to write this one, this explanation, because x is a liar. If negative 3 we say positive 3. So x is a real number, x shouldn't be equal to positive 3. So this is the answer you're going to give. 5.2. Write down the range of f. The graph of f is a parabola with a turning point at P. From the graph, the y-intercept of the turning point is the maximum value of the function. From the graph, we can see the y-coordinates of the turning point is the maximum value of the function. So the y-coordinates is going to be here. What going to be y-coordinates here? So this is a horizontal asymptote. So the x is equal to 3. So it's going to be a 3 coordinates of p, and the y is going to be a 8, because one is a vertical asymptote, one is a horizontal asymptote. So this is a vertical asymptote. Y is equal to 8. So this whole line is y is equal to 8. So the x, by the p, so p is the point of intersection. So both asymptotes, they meet here. So x value 3, y value 8. So which means the y value is 8 here. So the y coordinate of the horizontal asymptote of g is y is equal to 8. So this is a y value. So the maximum value of f is 8. This is the maximum value, 8. Now the range of f is all real number less than or equal to 8. Less than. Because the graph cannot go above this point up. The parabola is locked here. Can you see? It is locked here. So less than 8 all the way, you can see the less than 8 down. So you can see the parabola going down to both sides. Less than 8, less than 8. So therefore answer will be y less than or equal to 8. All the y value 8 is included, less than or equal to 8. That's my final answer. That's the range of the parabola. 5.3. Determine the values of x for which the first g of x less than f of x. I'll show you now. This means g below f. This means g below f. We need to see where g below f. So we're looking where is the hyperbola below parabola. So now we have to look from the point of intersection. So we only got the point of intersection here, this one. This is the point of intersection. So this is a point of origin. This side is a positive x-axis, this side negative x-axis. So first we need to look the negative x-axis side. There is no point of intersection because the parabola and the hyperbola, they don't meet each other. Now look on right hand side, which is a positive x-axis. So this is the point of intersection where both graphs meet each other. So you have to give the answer from the point of intersection. Whenever they ask you determine the values of x for which g of x less than f of x, which means g below f, so you, or any graph, so you have to give the answer from the point of intersection. So we need to, this is a comparison question, so you have to compare the graph, so you only can look from the point of intersections. So this is the point of intersection. Now, so we need to give the answer g of x less than f of x, g below f. So from this point of intersection you can see the g below f, and the x values here, and this is the x value here 3. Must remember this is asymptote, x value is 3 here. So between 3 and 5, that will be my answer. Between 3 and 5, g is below f. But now he say under the inequality, you can see the inequality underline. So now we have to underline. So which means 5 is included but 3 not included. Why? Because 3 is asymptote. So the graph cannot touch the asymptote. So this is my final answer. Second part he say f of x less than 6. So which means the y value is 6 here. Now we can see there is a y value 6. So we're looking f, which is a parabola, the less than 6. So we can draw this y line here. This is a y is equal to 6. We need to determine the values of x, which f of x less than 6. We need to determine the values of x for which f of x less than 6. F of x less than 6. This is the y value. So the y value is 6 here. So we need to give the answer in x values. So this we draw the horizontal line y is equal to 6. Now x value here, must remember, is 3. Don't forget, because this is x value 3 here. This is the horizontal asymptote of the g. So x value 3 here. So this is the axis of symmetry. This is the axis of symmetry for parabola. So the parabola half laying the right hand side, half laying on the left hand side. So this is the axis of symmetry. The parabola is even here. So if I have to an x value 5 here, don't forget. So from this is the axis of symmetry. From here till here, the length gonna be 2. 5 minus 3 is 2, because x right minus x left, 5 minus 3, answer will be 2. So the 2 units from 3, this must remember this is a 3 here, no, all the way 3. So this is 3 here. Between 3 and 5, the length is 2. So if you go right hand side, in the 3 you add 2, so become 5. If you have to go left hand side, 3 you minus 2, and that will be 1 here. So which means here is 1, because this is the axis of symmetry is 3. So if you add 2, become 5, and if you minus from the 3 2, and on the left hand side you have to go left hand side, then it's going to be a 1. So 1 and 5. So this is the value here is 1, and this is given 5. So the value here is 1, and this is given 5. Now we're looking less. So you can see the graph is, less going down, and here also less going down. So x value here 1. So x less than 1, the graph is all the way this side, the graph is down, 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 down. And this from this point x greater than 5, because all the way the graph gonna be down below the y value 6. So below the y value 6. So this is my final answer. So you're gonna say x less than 1 or x greater than 5. This is my final answer. 5.4, he says show that the equation of the parabola is f of x is equal to 1 negative 1 over 2 x squared plus 3x plus 7 over 2. We need to show that. But remember, this is the parabola standard equation, and this is a turning point form here because x value is 3 and the y value we got 8. So this is a turning point form. So we need to solve now here, and these are the points. D is the point on the parabola. So the equation of the parabola in turning point form is f of x is equal to a x plus p square plus q. Some of the school they're writing a negative, the same thing, because x is a line here. Now, so we're gonna sub this p 3 and 8 into this equation. So we're gonna substitute this into the f of x. So we're gonna substitute p into the f of x. So the a x value is positive 3, x is a liar, we're gonna say negative 3 square, and the q we got 8. So this we have f of x now. Now we need to find the value of a. So we're gonna substitute d to find the value of a. So the d x value is 5, y value is 6. So it's gonna be a 6 is equal to a place of x gonna be a 5 minus 3 square plus 8. So I'm gonna open up here. It's gonna be 8. This is gonna be a 2 square plus 8 is equal to 6. So 6 is equal to 4a plus 8. Solve for a now here. So 4a plus 8 is equal to 6. Solve for a here. So a gonna be a 4a. Positive 6 I pull over this side become negative. So negative 2. Therefore a is gonna be both sides divided by 4. So it's gonna be a negative 1 over 2. So we got the a. Now substitute a back into the equation now. F of x is equal to, place of a is gonna be a negative 1 over 2 and x negative 3 square plus 8. Now I'm gonna open up the perfect square formula here. So I'm gonna expand the equation. Negative 1 over 2, open up the perfect square formula, x square minus 6x plus 9 plus 8. Now negative 1 over 2 I'm going to multiply inside. This become negative 1 over 2 x square plus 3x minus 9 over 2. Positive and negative is a negative plus 8. I'm going to further simplify. So I'm going to simplify here. Negative 1 over 2 x square plus 3x plus 7 over 2. I use my calculator. So this is my final answer. This matches the given equation. 5.5, very interesting question. Calculate the length of MT. Now we need to calculate the length of MT. Obviously we need the coordinates of M and the coordinates of T. Then we can find the length of MT. So M is the x-intercept of F. So we set f of x is equal to 0. And we got f of x negative 1 over 2 x square plus 3x plus 7 over 2 is equal to 0. Factor the quadratic equation. Multiply by 2 to eliminate the fraction. Get rid of the denominator. So it's going to be a negative x square plus 6x plus 7 is equal to 0, and then negative I must multiply inside, become x square minus 6x minus 7 is equal to 0. Factor the quadratic equation. So it's going to be x negative 7 and x plus 1 is equal to 0. Now solve for x here. This is going to be x is equal to positive 7 or x going to be equal to negative 1. Now m is the negative x-intercept, so m going to be negative 1 and 0. M going to be a negative 1 and 0. So m is negative 1 and 0. This is m. Now we need to find the t. T is the x-intercept of g, so we set g of x is equal to 0. G of x is equal to 0. G of x we got is given already. This is g of x is given, negative 4 over x negative 3 plus 8. So the negative 4 over x negative 3 plus 8 is equal to 0 is given. So negative 4 over x, negative 4 x negative 3, positive 8, I switch over this side, become negative 8. The x negative 3 gonna cancel out here, so it's gonna be negative 4 is equal to negative 8 x negative 3 multiplied. So this is negative 4, this become negative 8x, negative become positive 24. Now I'm gonna solve for x here. So the negative 8x positive 24 pull over this side become negative 28. Both sides you divide by negative 8, the answer gonna be equal to 7 over 2. So the t gonna be therefore x value 7 over 2 and the y value 0. So therefore this t is gonna be a x 7 over 2 and the y value 0 here. So we got the points of m and t. Now we can calculate the length of mt. This is a horizontal length you can see. So I can use x right minus x left. So the length is going to be mt is going to be is equal to x right, which we got 7 over 2 minus x left, which is negative 1. Negative become positive. I use my calculator. 7 over 2 plus 1. The answer is going to be 9 over 2. Or you can say 4,5, same thing. So this is my final answer. You must say units. So the 5.6 is the last question. Determine the equation of the tangent to f at d. So this is the d here. So the tangent, obviously tangent touch once, meet once, remember forever. So this is the tangent here. So now we need to find the equation of the tangent. Now must remember, so we need to find the first derivative because this f of x we got here. F of x equation we have negative 1 over 2. So this is our f of x. So I need to find the first derivative of f of x. So it's going to be a first derivative of f of x is equal to this become negative x and this become positive 3. I apply the first derivative. I differentiate with respect to x. Now find the gradient find the gradient of the tangent at d. The coordinates of d are 5 and 6. We substitute x equal to 5 into the derivative. So we need to find the, at this point we need to find the gradient. So the first derivative 5, we substitute place of x is going to be a 5. Negative 5 plus 3, the answer is going to be a negative 2. Therefore, the gradient will be -2 because the gradient of the graph and the first derivative, they are equal at the point of tangency. Now we got the gradient. So we need to find the equation of the tangent line. Easy now. I'm going to use this formula. Y minus y1 is equal to mx minus x1. So I'm going to sub point of tangents, which we have d, 5 and 6 into this equation. So I substitute these points into the equation. So I'm going to solve here now. So the y -6 -2x, I simplify, this become +10. So therefore the y is going to be equal to -2x, +6, -6x I pull out this side, become positive, so +16. So this is going to be an equation of the tangent. Y is equal to -2x plus 16. So this is my final answer. This is the equation of the tangent line. Y is equal to -2x plus 16. I'm going to show you the question number 6 now. Now this is the question number 6 front of me. Most of the learners, they complaining that this question is very difficult. But to be honest with you, this is an interesting question. Let me show you how to solve this question. The question says, the graph of g of x is equal to x plus c and f of x is equal to a over x plus p plus q are drawn below. Graph g and the vertical asymptote of f intersect at the x-axis. So this is the vertical asymptote of f, and this is the graph g, they intersect here. The first question says, write down the coordinates of the x-intercept of g in term of p. Now, so this is the g. So he looking at x-intercept of g. And f of x is equal to a over x plus p plus q. So this is a positive p. You can see the x, this is a vertical asymptote. So the x value going to be equal to p here, because this is the vertical asymptote. So the x value is equal to p. X is a liar. If you have to put back into that equation, going to be -p. This is the standard equation. This is the standard equation he give you. And this vertical asymptote is x equal to p. So the x-intercept of g will be x value p and the y value gonna be a 0. So this is gonna be a x-intercept of g because x is equal to p. This is x equal to p here. So this is your vertical asymptote, x equal to p. Therefore x-intercept of g will be x value p, y value 0. So this is the x-intercept of g. Question 6.2. Graph G intersect the horizontal asymptote of graph f at x equal to 1 and the graph f at x equal to 3. Graph G intersect the horizontal asymptote at x equal to 1. So the graph G intersect the horizontal asymptote at x equal to 1. So this is x equal to 1. This is a horizontal asymptote. So x value here is going to be a 1. And x equal to 3. So the x value 3 is here. So he's intersect at x equal to 3. Because f at x equal to 3. So the G intersect the horizontal asymptote here, x equal to 1. And G also intersect the graph f at x equal to 3. So this is the graph f. So at x equal to 3 here. So this is the G. The graph f and G intersect on the y-axis. Obviously this is f. This one is f and this straight line is G. They also intersect on the y-axis. So this is a y-axis. So they intersect here. Determine the equation of f. So we need to find the equation of f. I'll show you how to solve this question. So this is the equation of f of x. So this is the equation of f of x. So we can solve algebraically according to these equations what they give us, or we can first look the graph, and according to the graph we obtain the equation, and then we can solve this question algebraically, but answer gonna be exactly the same. But if you take as is these equations and you equate, and that will be easy. But otherwise you have to first modify these two, and then you have to solve algebraically, but answer gonna be same. For if you want to do, this is the first method. I would like to solve according to these equations, but if you want to do other way, that it will be like this: f of x. Then first of all I need to modify. Now a, obviously we don't know, but x is a liar. X plus p, we can't say x plus p because x is equal to p here. This is a vertical asymptote. X is a liar. If I have to put back into this equation, it's gonna be x negative p. Now obviously the q below the x-axis, this is a positive x-axis, below the x-axis, so the y is equal to negative q. We don't know which one, so that's negative q. Y value gonna be a negative, so it's gonna be a negative q. And g of x as well, that will be x negative c. And then according to these two equations, and you substitute the point and you solve, you will get the same answer. But if you go according to these equations, that will be easier. Why? Because we don't have any information, so we're gonna equate these equations. But I would like to use these standard equations, and then I want to solve algebraically. Either way, answer gonna be same, this one or that one. Let me do according to these two, but I'm gonna use these two. So we have the asymptotes. We got two asymptotes. This is a horizontal asymptote, this is a vertical asymptote. Then we got y-intercept, this is a y-intercept, and then we have point of intersection, this is here point of intersection. Then we have the variables p, q, a, and c. So we're going to utilize these information to solve this question. So these are the information I'm going to utilize. So let's do first asymptote. Remember, if you got f of x is equal to a over x plus p plus q. So if you got, as usual, hyperbola, so first always we find the p, then q, then we look the extra point on the hyperbola, then we solve for a at the last. So we're gonna follow the same we're gonna follow the same sequence. So let's start. So first of all, p. Now must remember, in question 1 we say the x-intercept p and 0, so that we look according to graphically, because x lies by the positive x-axis, that's why we say x is equal to p, and here p is x is p, y value is 0. But now this one we're going to solve according to the equation of the graph which they give us. But this one we will solve according to the equation of the graph. Given equation, we don't know, we have no other information, so we're gonna solve according to this equation. Now here, this is the asymptote, vertical asymptote. This is a vertical asymptote we have. So here x plus p, this is a vertical asymptote, is equal to 0. X is a liar, x gonna be equal to positive p become negative p. Now, so this is the vertical asymptote according to this equation. Graph G and the vertical asymptote of f intersect at the x-axis. So This means x-intercept at G is same as the vertical asymptote of F. So the G of x we have is equal to x plus C. Remember, I told you I'm going to use this one. Remember, I told you I'm going to use the standard equation. We're going to solve algebraically. Now, x-intercept we need to find if this one, the y value must be equal to 0. So x plus C, this is a y value 0. And now, x positive C become negative C. Therefore, x value going to be a positive C, as switch over this side become negative C. This is x equal to negative p, this is x equal to negative c. So both are equal to same thing. We can say negative c is going to be equal to negative p. So I can say negative p is equal to negative c. This side, so negative p is going to be equal to negative c. Both sides you multiply with this negative cancel, so the p is going to be equal to c. So there we go, we found the p already. So there we have the p. Must remember, we need this one later stage. Now, so p we have, because now we need to look the q here. Now we're going to utilize the horizontal asymptote, because we busy with asymptotes. Because he say graph G intersect the horizontal asymptote of graph of f at x equal to 1. Now this equation, horizontal asymptote will be this one. Y is equal to q. This is horizontal asymptote. So G intersect the horizontal asymptote at x equal to 1. So which means, so x value 1 and the y value will be q. Now we substitute this one into y is equal to x plus c. So y gonna be q, x is 1 plus c. So therefore this is the value of q, 1 plus c. We also need this later stage. Now we're gonna try to solve the a. So now we're gonna utilize the y-intercept. Remember, he say f and g also intersect at y-axis. So here they intersect here. This is the y-intercept. They intersect here. We're not solving this one according to graphically. We are solving according to equation. We will substitute the relevant values into the equation to find the equation of the hyperbola. We will substitute the relevant values into the equation to find the equation of the hyperbola. So the y-intercept is a point of intersection. This means they have the same y-intercept, y-intercept of G and the y-intercept of F. They are same, because y-intercept x value must be equal to 0. So which means y is equal to x value becomes 0 plus c. So therefore y-intercept will be, therefore y is equal to c. So the y-intercept is x value 0 and y value is c. Now we're going to find the y-intercept of f. That also x, where the x must be equal to 0. So we got y is equal to a, place of x going to be 0 plus p plus q. So that will be y is equal to a over p plus q. So which means x value is 0 and the y value is a over p plus q. So this is the y-intercept of f. Now Now y is equal to c, y is equal to a over p plus q. They are both equal to same thing. So same y-intercept, so I can say c is equal to. So this become my number 1. Now we need to solve the a, so I'm going to substitute what we have earlier found. P we have is equal to c, must remember, and q also we have, that was equal to 1 plus c. So I'm going to substitute into in this equation to find the value of a. So the c as is, a we don't know, place of p gonna be c, place of q gonna be 1 plus c, plus 1 plus c. Now I'm gonna solve for a here, a over c. This positive c as switch over this side become negative c, positive c and negative c is 0, and positive 1 as switch over this side become negative 1. Now therefore cross multiply, a is gonna be equal to negative c. So we got the a as well. The graph f also intersect at x equal to 3 here. So I'm going to use the point of intersection now. So now I'm going to use the point of intersection to solve for c. Remember, these 3 variable we have, c we don't have. So which mean g of x must be equal to f of x. So the g of x we got equation x plus c, and f of x we got a over x plus p plus q, that we have. Now at x equal to 3, which means x value 3 plus c is equal to a, x value 3 plus p plus q, because of this we're using the point of intersection. Now this become my number 2. All of these value what we have, we're going to sub into the 2 to get the c value. So now 3 place of c, 3 plus c we don't have, is equal to, place of a gonna be a negative c over 3, place of p is gonna be a c, and place of q gonna be a 1 plus c, plus 1 plus c. Now I'm gonna solve algebraically to find the value of c. There's 2 ways to solve. I can get rid of the denominator, or I can solve for c here, same thing. So this positive 1 and plus c, if I switch over this side, become negative. So it's gonna be a, I'm gonna take this question this side, 3 plus c, this become negative 1, and negative c is equal to negative c over 3 plus c. So negative and positive cancel, positive 3 and negative 1 is only left positive 2, and this become negative c over 3 plus c. I'm going to cross multiply, negative c is going to be equal to 2 multiply 3 plus c, 6 plus 2c. Now negative c, this pull out this side become negative 2c, and this becomes equal to 6. This negative 3c is equal to 6. Both sides you divide by negative 3, the answer is going to be a negative 2. So c value is negative 2. Now I'm going to determine this equation, and I'm going to use these values. So wherever you see the c, you put the negative 2. So the p is equal to, place of c here is going to be negative 2, and the q, place of c, 1 minus 2 is going to be a negative 1, and this is done, and the a is equal to negative c, so the a is going to be negative c, negative become positive, it's going to be positive 2. So the a is positive 2 and the c is already we got negative 2. So we all these 4 variables we have, we're going to substitute into this equation to find the equation of the hyperbola. So therefore f of x is going to be equal to a, we got positive 2, so the 2 over x. Now p we have negative 2, so we say negative 2, and the q we got negative 1, I say negative 1. So this is the equation of the hyperbola. So you can see x is a liar, is this, which means this asymptote x is equal to positive 2 and the q is negative 1, so which means y is equal to negative 1, and this is the point this is the point of intersection of the asymptote. So it's gonna do x gonna be 2, y value negative 1. Question 6.3. Describe the transformation that G must undergo to become an axis of symmetry of F that cuts F at 2 points. So we need to find the axis of symmetry now. So the axis of symmetry passes through the point of intersection of the asymptote. So this is the asymptote here, must pass through here. So this will be the axis of symmetry. So axis of symmetry with a positive gradient we have, so we say y is equal to x plus c. Now here this one is a y value we got negative 1 and x we got positive 2. So the positive 2 and negative 1, these are the point here, because this is a vertical asymptote, x is equal to 2, this is a horizontal asymptote, y is equal to negative 1. Now we're going to substitute these points into that equation to find the c. So we got x2, y1, negative 1. Negative 1 is equal to positive 2 plus c. To find the c, positive 2 I switch over this side become negative 2. Negative 1, negative 2 is equal to c. So the c is going to be equal to negative 3. Therefore, y is equal to x, and put back value of c here, become negative 3. So this is my axis of symmetry, this one, y is equal to x negative 3. And the g of x we have x negative 2. Remember we earlier found because c value was negative 2. So the g of x we got x negative 2. Now the transformation is a vertical shift of 1 unit downwards. So that 1 unit downwards. So the graph of G must undergo a vertical shift of 1 unit downwards, then become axis of symmetry. So you're gonna write the statement. So you're gonna say therefore G of x shift 1 unit downwards. G of x shift 1 unit downwards. So this is my final answer. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day. I'm going to upload next financial math video.